Hello. So in this video, we're going to take a look at lecture 3.3 costs number 1. And up to this point, we've kind of been generically talking about costs a little bit. But for this one, we're going to get into the weeds of some of the technical details of the different measures of costs. And hopefully for each one, I'll explain why the shape looks like it does of it if you were to graph it, and why it's important. Like, why do we care about this particular measure of cost? So hopefully you can kind of see your notes here. You've got 4 different types of costs: marginal cost, average fixed cost, average variable cost, and average total cost. And each one of these is what we call a per unit cost, which means that it's actually like for a specific number of units. It's like for the 17th unit or the 3rd unit or something along those lines. So we would say, what's the average variable cost of the 3rd unit, or what's the marginal cost of the 8th unit, or something like that. Then we're going to graph those per unit costs down here as we talk through them. So you're given a table, this quantity of inputs, and this is the same data table that we used already in this unit. And so the downside of using the same data table is that some of these numbers are not going to be nice, like round numbers. On a test, you're not going to be needing a calculator like what I've got pulled up over here. But for this one, I think it's useful to work through these with a calculator as you're kind of working through them. So what you're given is the quantity of input. That would be the number of workers, right? So here we've got number of workers, and then you've got, this is how many product they generate. So when you have 1 worker, they generate 8. When you have 2 workers, they generate 18, 3, 26, and so forth. And then you're given some total costs here. You're given total variable cost. That's what VC stands for. You're given total fixed cost. That's what FC stands for. And you're given total cost, which is TC. So here is total cost. And you can see that if you add 0 and 50, you get 50. If you add 25 and 50, you get 75. So the fixed cost plus the variable cost, add those two together, you get the total cost. And what we're going to find is that actually if you add average variable cost, average fixed cost together, you're going to get the average total cost by how we calculate these. So let's start off with marginal cost. This is probably one of the most important curves in all of microeconomics. It's the change in the total cost divided by the change in the output. Now, normally, you'll probably see this as change in total cost, given that you change output by 1 unit. So it's just change in total cost over 1. But it is important to recognize that it's actually the change in cost associated with any given change in output. And so in this circumstance, right, our changes in output are not going to be 1 every single time. So we're going to be dividing by a different number. So let's actually start with marginal cost in this one, and then we'll kind of work from there. So I've got the same data table down here, but I've gone ahead and solved the marginal cost here. I'm going to show you what that looks like in terms of the calculator. So it's key to understanding how to maximize profit. Remember that we have MR equals MC is our optimal output rule, or our profit maximizing rule. And so we need to know what the MC is at every unit here to see where we should produce. Now we're going to find that it has a J shape. It's got like a Nike swoosh is another way to describe it. It looks kind of like that, or a check mark. And it's going to initially go down because the workers are going to start to specialize. But then at a certain point, you kind of run out of the gains of specialization, and it's overwhelmed by diminishing returns, right? You have a fixed input and you have too many workers, so they're going to end up squeezing, and they can't get any more out of it. And so the additional cost of each unit of output starts to rise. So that's by way of saying that's why it starts to go back up again, diminishing returns. So let's go ahead and solve marginal cost here per unit on a per unit basis. So there isn't going to be one for this 0th worker, right, for 0 products, because there isn't a change. But going from 0 workers to 1 worker, our total product changes by 8. And so I'm going to write up here change in total cost divided by change in total product, because it's the change in total product. Now, change in total cost, we have 50 to 75. That's the amount of the change here. So we'll just say 25 divided by, and we'll say 8 divided by 8. So it's $3.13 for that first, hiring that first worker. The 8th total product, the marginal cost of the 8th unit is $3.13. Now we're going to do the second one, but notice that again here we go 8 to 18, so it's going to be to 10. So in this one, what's our change in cost? Well, our change in cost is 25 going from 75 to 100 divided by 10, right? And so that's $2.50. And now we're going to do the next one. The next one is the change in total product is 8, going from 18 to 26, and the change in cost is still 25. And the reason that we're doing that every time, why that change in cost is staying the same, is because we're actually just changing the number of workers that we hire each time, and each worker is costing us $25. So we can see we initially went down, marginal cost went down 313 to 250, and then it starts going back up again. And what this tells us when it's higher now is that we have diminishing returns to labor starting to set in with the third worker. Now let's go ahead and do the fourth worker. Let's see here, 25 is how much it costs. That's the change in cost divided by the change in total product, which is 6. That should give us 417. And we're going to see that it's going to get larger and larger as we do more of these. Divided by 4, 625. And for this next one, 25 divided by 2 is 1250. So it's going to rapidly go up, right? Zoom right up. And again, why is that? Well, the change in cost is staying basically the same because every time we hired a worker, it's 25, but we're getting less product out of each and every one of these workers. And that's the diminishing returns to labor. So that's why it's got that upward slope to it. So we're going to go ahead and graph that one down here. Quantity, price, and we're going to do wee just like that, right? And you can even make that noise wee if you really like. Okay, now the next one is called average fixed cost, and this one's actually really not that important. It's of so little importance that I'm not going to put it on this graph down at the bottom. I'll draw a graph off to the side to show you what it looks like, but it doesn't really have any value for us. But it does help us if we calculate some other values, right? So I'll point that out when we get there. This one's going to have kind of an L shape. It's going to start high and then it's going to go down. So let's go ahead and calculate this one. It's the total fixed cost divided by the quantity of output. So it's a total divided by a total. So we have the per unit, we have fixed cost, total fixed cost divided by total product. Okay, so notice that it doesn't have these deltas because it's not a change. It's a total divided by a total. And so our total fixed cost is going to stay the same because it's fixed, right? So it's 50 divided by whatever this number here is over on the side. So 50 divided by 0 isn't going to be a value, but if we were to have like an infinitesimally small number, it would be very close, we'll say very close to 50. So if we only had 1 unit of output, the average fixed cost would be 50. It'd be 50 divided by 1. So it's close to 50, but we know that it's undefined. Now let's do the second one, 50 divided by 8. So 50 divided by 8 is 625. So you can see that it drops pretty rapidly. I'm going to go ahead and advance these slides here. It's going to drop pretty rapidly as more output is produced. So for the next one, we have 50 divided by 18, and that gives us 278. And then we'll do 50 divided by 26 is $1.92, and 50 divided by 32. 50 divided by 32 is 156. And we're going to see that it's going to get smaller and smaller as we go along because we're spreading out the units. We're spreading out the fixed cost over more units. So divided by 38 here, 132. So you can see it starts out really high, pretty rapidly drops, and then it's going to start to flatten out. Now, eventually, in theory at least, right, we're going to spread that fixed cost over just an infinite number of units. And so it would get infinitely close to the x-axis, but it's never going to be touching. So we call it an asymptote, right? So if we were to graph it, right, like here, it would start here, and then it would go really small and get really, really small and small and small. So I'm going to put it off to the side over here just so you can kind of see what it looks like. It does one of those. So AFC. Kind of, oops, you can't really see that in the light there. That's been there. So AFC. Okay, let's take a look at average variable cost. This one's actually going to become important. This one is the total variable cost. Let me see if I can turn off. Nope, that doesn't help. That's the sunlight coming in. So this one is the total variable cost divided by the total product, the quantity of output. So it's pretty similar to average fixed cost in that it's just the total of the variable cost divided by total product. This one's important because it's going to help us know whether the firm should keep operating even if it's losing money. And we'll take a look at that one in the next unit. We're going to note that it always gets closer and closer to ATC graphically as output rises, but it's never quite going to touch. We're also going to note that marginal cost is going to come right through the minimum point of the AVC. And it's going to have a U shape. So it's going to go whoop, just a U. And right through the bottom of that U is going to be this marginal cost curve. So I'm going to go ahead and put that one on here. It's going to come down. My suggestion is come down, take your pen off, and put a dot, and then come back up again. And it can even be kind of like a V, almost like that, a wide-mouthed V. And that's our AVC line, okay? So we noticed that that point is the minimum of the AVC, and it has to be going through the MC there. That's why I encourage you, draw down, stop, move your pen up. Now, let's go ahead and calculate what this one looks like. So we have total variable cost divided by total product. So we're going to go ahead and advance the slide, and we'll see if these numbers kind of align with what we've got here. Variable cost, again, we have 0, so we're not going to have one there. But for the next one, it's going to be 25, right? Because it's this number, variable cost divided by 8. So that's 313. And then the next one is 50, because again, these are the totals. So now we're going to use 50 here, divided by 18 is 278. So it's coming down. And then we've got 75 divided by 26, 288. So now it starts to come back up again. And 100 divided by 32 is 313. So it's still coming back up again. And 125 divided by 36 is 347. And 150 divided by 38 is 395. So we can see that, right, it starts 313, goes down, and then immediately it's going to start coming back up again. And notice that this point where marginal cost was at its minimum, right, 250, that's where it was at its lowest, is also the point where AVC is going to hit its minimum. And it's crossing through kind of in that point. Now, I'm just going to say that that's a weird like coincidence. On our graph down here, I didn't draw it that way. It's a weird coincidence that those two things are occurring at the same level of quantity of input. Okay. Now, the last part is going to be average total cost. Okay, so this one, there's two ways that we can calculate it. We can say it's just the total cost divided by the total product. That's one way to do it. And I'll show you the first one that it does hold true. Or it's AFC plus AVC. And that has to be true because if fixed cost plus variable cost equals total cost, right, then if we divide all of that by the quantities, like the total product, then that's saying the average fixed cost plus the average variable cost is the average total cost. So those are the same statements, right? Fixed cost divided by total product is AFC. Variable cost divided by total product is AVC. Total cost divided by total product is ATC. And so you can solve this kind of one of two ways. You could say it's the total cost for ATC. It's the total cost divided by the total product, or it's just add these two numbers together. And so for the first one, this ATC isn't going to be really in existence. So we're just going to put like a, And in theory, it's quite close to 50 because that's the AFC value for that level. But if we now take a look at it, we'd say this one should be 313 plus 625 should be 938. So that's our best guess of what that's going to be. Let's take a look. Let's see. Well, the total cost is 75 divided by the total product, which is 8, divided by 8. 937. So that is 938. Look at that. So again, it's this AFC plus the AVC, right? You add those together and it'll give you the ATC. So 278 plus, in this case, 278 is 556. Now, we're going to go ahead and test that just to show you that this holds true, the total cost divided by the total product. So total cost is 100, 100 divided by, and our total product is 18, 556. So again, it's correct on that one, right? So now total cost is 125 divided by total product of 26, and that's 481. And then for the next one, 150 total cost divided by the total product, which is 32, 469. And what do we notice? We notice that ATC is coming down. And then let's see what happens to this ATC value. Well, we've got 175 divided by 36, 486. Now it's starting to come back up again, 486. And then we'll do the last one, 200 divided by 38 is 526. And so we find it behaves similarly to the AVC. It's going to come down, come back up again. And so let's take a look here what we have. It'll do one of these, come down, hit its minimum, and then graphically, it's going to get closer, and technically the AVC and the ATC are going to get closer and closer together. So I'm really sorry about that terrible glare there. But the ATC is going to get closer and closer to the AVC, and that's because the vertical distance between these two lines is actually the AFC. It's the distance between the two, and that's because the AFC is getting smaller and smaller. So in fact, the distance between the two is going to get smaller and smaller as AVC, let's take a look up here, becomes a larger and larger portion of the ATC. All right, so take a look. 395 and 132, that 395 is a big chunk of the 526. But if we go back all the way to here, earlier, most of the average total cost of that 938, most of it was coming from the average fixed cost. And so you can see that over time, as you produce more and more units, the AVC represents a larger portion of the average cost of the units. Now, this is important because it's going to tell us whether the firm's earning a profit or a loss. And so again, we're going to use these curves later to do important work. But the big three are AVC, ATC, and MC. And pretty much the reasons for why the shapes they are all pretty similar. You have this spreading effect that we're spreading out the fixed cost over more quantity, and then eventually the diminishing returns to the input start to set in, and it starts to bring those costs back upwards. All right, so I know this is technical stuff. It's pretty challenging, I get it. Check out module 55 if you need a little bit more explanations. I'll see you next time.